All right, let's do some more molarity problems. The molarity problems I'm looking at doing are going to be on page 4. You know what? And a good place to start is just letter A. So page 4, and this is 1A. We'll do a couple of them. Let's see, it says 3 moles of sugar dissolved in 2 liters of solution. Well, that's pretty simple, right? 3.0 moles. 2.0 liters equals 3 divided by 2. I believe that's 1.5. 2 sig figs, 1.5 molar. At the bottom, you're going to see some stuff. This is my buddy Kevin in Birmingham Groves. And some of the things that I got from him are here. And what you're going to see is you're going to see at the bottom, you'll see some answers. You'll see in random order. It says answer, IRO, means in random order plus 1, meaning one that does not belong. Okay, so IRO plus 1. And then at the same time, there are units, IRO plus 1 as well. So there you go, 1A. Pick another one. Let's see. Let's do 1D now. So for 1D, what you'll see is you'll say you have 350 grams of KNO3. And I believe that's 350, no decimal place, grams of KNO3. So the molar mass of KNO3, well, grams of KNO3 in 1 mole of KNO3. That number is 101.11 grams, all right? You do the math on this, and you get, I have 3.46. So when you take that number, and by the way, I'm not caring about significant figures yet. I'll care about significant figures in a minute. So that's moles. 3.46 moles divided by, in the problem you are told, 5 liters of solution. So when you take that number and you divide it by 5, then you're going to now go for the 2 significant figures that you should have gone for at the beginning. So the answer is 0.69 molar. Let's go ahead and do one more. Just going to kind of scare down the page on page 4 for a second here and look for one that'd be a good one. All right, let's do number 4 now, because this one's got some quirks to it. So it's a little bit of a backwards one. It says how many grams of NaNO2 are needed to make 3.5 liters of 0.5 molar solution. So, first of all, we need to remember that molarity is equal to moles per liter, right? Well, the problem here is you're asked for grams. So you're going to have to do, actually, you're going to figure out the moles. You're going to have to take the moles, turn it into grams. Here's how we do that. So we say, okay, we have 0.50 molar solution, right? And that is going to be equal to moles over 3.5 liters. Well, we multiply both sides by, 3.5, and you get moles equals. Now, for now, I'm not going to care about significant figures. I'll do it at the very end. So, 1.75 moles, and what is that moles of? The substance here is NaNO2. So now, we got to take that 1.75 moles of NaNO2 and turn it into mass. Well, I like dimensional analysis. In 1 mole of NaNO2, and the reason I'm putting it on the bottom is because I want to cancel moles to moles, how many grams of NaNO2 are in 1 mole? Well, that's called the molar mass. And I calculate the molar mass to be, I have 69 grams. That's 22.99 plus 14.01 plus 2 times 16. It's 69 grams. Equals. Take 1.75, multiply by 69. Now I'm going to account for the 2 significant figures that I needed, okay? So when you get 100, when you do the math on this, you get 120.75 grams of NaNO2. You go to find that answer at the bottom, right? Because it says in random order, you can check your answers. Well, you don't see an answer there, and the reason is because this is the wrong number of significant figures. This answer is only allowed because of here and here. to have two significant figures. Therefore, this becomes 120 grams of NaNO2. And the final answer of 120 can be found.